Good morning. We are on page 65 of the notes spiral, and we'll be talking about standardizing with z-scores. So this is a continuation of our discussion with standardizing with z-scores. So we're going to look at an AP question, 2011, question 1. Admittedly, I removed part A because you don't know how to do it yet, but part B and C you do. And this will give you a good idea as to what to be thinking about. So a professional sports team evaluates potential players for a certain position based on two main characteristics, speed and strength. Speed is measured by the time required to run a distance of 40 yards, with smaller times indicating more desirable or faster speeds. In other words, I would be rather to be running at 4 seconds, and I'd like to be running at 5 seconds. So the smaller the speed, the smaller the value, the faster I was. From previous data for all players in this position, the times to run the 40 yards have a mean or average speed of 4.6 seconds and a standard deviation of 0.15 seconds with a minimum time of 4.4. So here we have it in the table, the average time of 4.6, the standard deviation of 0.15, and the fastest that anyone ran, which is 4.4, which is 0.2 seconds faster than the average, okay? Strength is measured by the amount of weight lifted, with more weight indicating more desirable or greater strength. In previous strength data for all players in this position, the amount of weight lifted has an average of 310 pounds and a standard deviation of 25 pounds, as shown in the table below. So on average, the players were lifting 310 with a standard deviation of 25. Calculate and interpret the z-score for a player in this position who can lift a weight of 370 pounds. Well, basically, we know the 370 is above the 310, so we should be expecting some sort of positive z-score. All right. Now, please note it says calculate and interpret. Very important you do both. Not just calculate, you also have to explain what it is you found. So, writing our formula, z equals x minus mu over sigma, we show our work. The average was 310, the standard deviation was 25, and the value lifted was 370. And sure enough, we ended up with a positive z-score of 2.4. So a player who can lift 370 pounds is 2.4 standard deviations above the mean for what? For players at that position. So relative to other players, this is a fairly strong guy or lady at 2.4 standard deviations above the mean. Part C, the characteristics of speed and strength are considered to be of equal importance. So in other words, it doesn't matter. I mean, they're both really important, equally important. We don't weight, one of them is not weighted more importantly than the other in selecting a player for the position. Based on the information about the means and standard deviations of speed and strength for all players and the measurements listed above in the table for players in B, which player should the team select if the team can only select one of the two players? Justify your answer. So here's what we have. Player A can run the 40 in 4.42 seconds, which is faster than player B at 4.57. However, player A lifts a little bit less than player B, lifting it, and so we need to make a decision because player B is stronger, player A is faster. Who are we going to choose? Well, this is where we can use z-scores to make a comparison and make a decision. And this is probably what really did go on. So we know that the average speed was 4.6 with a standard deviation of 0.15. I should back up for just a moment. So we have running and we have speed. So we have speed and we have lifting, and we have two players. That means we're going to have to do running for both players, z-scores, and we're going to have to do our speed for both players, and we're going to have to do lifting for both players. So I end up with 4.42 minus 4.6, the average, divided by 0.15, and I end up with a negative z-score of a negative 1.2. And that is because his time was less than the average. Now, the good thing is we want a time less than the average, so we'd like a negative z-score for speed. All right? When we do the same thing for player B, we end up with 4.57 minus 4.6, the average. And we find out that player B also has a negative z-score, which we would expect, but it's much closer to being 0. So basically we have two players. Player A is faster than player B, which we already knew, and it looks like they're about 1 standard deviation faster, because one's a negative 1.2 and the other is at negative 0.2. So player A is 1 standard deviation faster than player B. When we go to lifting, we've already done this. 370 minus 310 divided by 25 is 2.4. So player A is 2.4 standard deviations above, and we want them to be strong, so that we want them to be lifting above the average. So we want the positive z-score in this case. And player B is that we did his, and we end up with a 2.6 standard deviations. Okay, so basically we say that player B is about 0.2 standard deviations stronger than player A, and player A is about 1 standard deviation faster. So let's write this up. And before we write it up, let's talk about who we want. Well, I'm going to say that we want player A because he's a full standard deviation faster and only 0.2 standard deviations less strong. So player A is probably the better choice between the two. So whenever we're doing any sort of writing for College Board, we need to explain what it is we did and found, and then we need to explain our decision. All right? And by the way, it is important that you make it as a decision one way or the other. You can't say it depends. We do not get to be Switzerland. We have to make a decision and stand on it. So player B is slightly stronger than player A and is able to lift a weight that is 2.6 standard deviations above the mean versus player A being able to lift 2.4 standard deviations above the mean. Player A is substantially faster and is 1.2 standard deviations faster than mean versus player B, who's only 0.2 standard deviations. So far, I've just reported my results. Even though player B is 0.2 standard deviations stronger, should be a comma, I would choose player A because he's a full standard deviation faster than player B and only slightly less strong, and both speed and strength were equally weighted in the decision. So it's really important that you give a decision and you give it in context, and you also need to summarize what it is you found, and that needs to be true for any AP statistics question for the remainder of the year. So see, you can use z-scores to make comparisons for different people, all right, or different things to make a decision.